Okay, somebody yesterday told me that they watched my videos, but my voice was too quiet. Who said that? Was that you? That was you, Prez. I just watched a video last night, and I watched with my daughter. And you know what she said to me? Daddy, why are you talking so loud? It hurts my ears. Did you watch the most recent video? Oh, if you watched last year was a different microphone. I spent $50 on this bad boy. Picks up my voice great. You know, Ben Jones actually said that he found my voice soothing. He listens to my videos before he falls asleep at night. That's because you missed me. That's because we have a special connection. That's because it's the dumbest theory ever, made. I mean, it's completely incorrect. Yes, thank you very much, Miss Fully. Okay, this is a democracy. Raise your hand if you want Ben Jones to stay in here. Oh, what happened? What's up now? Mallory, no, that's not. Mallory, you just gave in to peer pressure. Oh my gosh. Oh. Okay, let's get started on the basics. Inequalities. We start with inequalities. You need a review. We're going to try easy inequalities today, difficult inequalities tomorrow. Linear inequalities. These are easy. This is all a review from last year. So, example 1. Solve the following inequality. Graph the solution set and write it in interval notation. So, we have 3 things. Solve, graph, interval notation. In order to solve this, I add 7 to both sides. Negative 2x is less than 16. Then what? Divide by negative 2. What? Why? If you multiply or divide both sides by a negative, flip the sign. Now, this is the important part, everybody. By. A lot of people think it's if you multiply a negative or divide a negative. It doesn't matter if you're multiplying or dividing a negative. You have to divide by or multiply by a negative. Totally different scenario. So we have x is greater than negative 8. That's the solution. I now need to graph it. What do I plot? Negative 8, open or close circle. Open, arrow left or right. Right. Very good. Interval notation. What are my 2 endpoints? Negative 8 and what? Very good. Parentheses, brackets, both. Parentheses. 3 pieces. Can you do all 3 of those? Good. Then we're good to go. So, linear inequalities, you should be able to solve anything like that. That's child's play. You guys can do it. No problem. Compound inequalities. Well, a little bit different. Compound inequalities are 2 or more inequalities. Again, we want to solve these. We want to graph them and represent the solution in interval notation. So here we have negative 9 is less than 3x minus 7, which is less than or equal to 11. Now, for the sake of consistency, I'm going to teach it the way that I think you were taught most often, the way I'll continue to do it. But just note that there is one way you can solve for this, and that is if you want to get rid of this negative 7, you can add a 7 to both sides of that piece. So if you add it out of the middle, then you add it to both sides, and you get, your negative 2 is less than 3x, which is less than or equal to 18. And then you can divide by 3 the same way. But I won't do that. I'm going to set up 2 inequalities. What does conjunction mean? Give me an example of a conjunction in English. What's a conjunction in the English language? A word that puts 2 sentences together, which would be, and would be a very common one. So it brings things together. What is a disjunction? Separates it, puts it apart. So we'll look at a disjunction in a little while. This is our first conjunction. We have negative 9 is less than 3x minus 7. That's our first one. And then our second one is 3x minus 7 is less than or equal to 11. I solve each independently. I graph their solution set on the same number line. Add 7 to both sides. Negative 2 less than 3x. Divide by 3. Negative 2/3. Flip the sign. Why would somebody flip it? Why would somebody be tempted to flip it? Because you see the negative 2. But, of course, as Jensen said, you do not flip it. Jensen is very smart. Can't get anything by her. So, we add 7 to this side. 3x is less than or equal to 18. Divide by 3, and you get x is less than or equal to 6. So I graph these on the same number line. I have a negative 2/3. I have a 6. Open or close circle on each one. One's open, one is closed. Does it come together or do they go apart? They're together as you read the signs. So I have the solution, I have the graph, I now need the interval notation. Interval notation, parenthesis, negative 2/3, comma, 6, bracket. Done. Any questions on that? Okay. A disjunction, they go apart. If we simply divide both sides here by a negative 4, we get x is greater than negative 2. If you add 3 to both sides here, we get x is less than negative 5. Again, I go to my number line, so that is my solution. The or stays in between. Negative 5, negative 2. Both are open circles. That's my graph. Somebody give me the first interval for the solution set. Very good, Bailey Barber. Negative infinity, negative 5. Or negative 2, positive infinity. Does it just make you happy to write that expression infinity? It is a beautiful symbol, isn't it? Tell me, when you were in algebra class, did anybody ever tell you that you could have a line with an infinite slope? Of course they would not have. That would simply be foolish. All right. Ahead of your time, yeah. Archimedes, 2,300 years ago, proved you wrong. All right, solve a graph. The following inequality represents the solution set in interval notation. Now we get to the meat and potatoes of what we need to do. Okay, and we'll kind of end with this type of example. But this is a very, 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 very good example. This is easy. You guys will be able to do this, no problem. However, I don't want to just do problems like this. This is boring. I want to do problems like this. X squared minus 5x plus 6, don't write this down, over x squared minus 1 is greater than x minus 3. I want to do inequalities like that. And Bailey Barber says, why would you ever want to do inequalities like that? This is much more interesting. Yes, well, more difficult is more fun. Oh, no. Somebody embrace this. Say, I want to do this. And I get no response. Morgan Haney, where is your excitement? Morgan, when you're trying to get pumped up for cross country, what do? You just run. Okay. Well, when I get pumped up for math, I just look for a tough problem and I go after it. Well, let's try the easy ones first. We will regress to the mean. We will take Bailey Barber's advice and say, let's look at the easy ones first. So we're going to do two methods. We're going to do a graphical method, and then we're also going to do a table method. You must be able to do both. Okay? This one is easiest to do by graphing. We'll do that first. And then I will show you the interval method afterwards. The previous problem I just put on the board for you, I expect you to be able to do that by the end of this, in the end of this week. And if you want to be able to do that, you have to use the table method. And Casey's looking at me like I'm nuts. Trust me. Look at the people I got through it already. You see them back there? Ella, Megan. So I have x squared plus 2x is greater than 15. I'm just going to switch that a little bit. Right, as x squared plus 2x minus 15 is greater than 0. Let's just think about that for a second. That's very important what I just wrote on the board. Greater than 0. What does it mean to be greater than 0? It's a negative? Not a negative. It's a positive. There you go. If I tell you that your bank account is greater than 0, are you happy or sad? You're happy because you have positive amount. So yes, this is positive. That's what we're looking for. In fact, we're wondering, where is it positive? Where is this expression positive? So I'm going to graph this. You tell me, when I graph something, okay, when it's above the x-axis, is it positive or negative? It's positive. When it's below the x-axis, is it positive or negative? It's negative. So I want to graph this and see where it's above the x-axis. So this will be no problem. In order to graph it, I'm simply going to factor it and find the x-intercepts. Hey, what's going on? Oh boy. Yep, there goes the light red. And please turn back. Smartboard work. Oh no. Light's red. We'll unplug it. Plug it back in. I wonder if the recorder still works. Okay. Recorder still on. There you go. Nice job, recorder. Okay. So here we go. X plus 5 times x minus 3 greater than 0. What are my x-intercepts? Negative 5, positive 3. So if I graph this, and I'm kind of cheating. I only have one variable here, yet I'm drawing a 2-variable axis. But it's okay. We have a means to an end. Negative 5, positive 3. Does this graph go up or down? What shape does it make, first of all? Parabola. Is the parabola going up or is the parabola going down? How do you know it's going up? It's a positive x squared. So therefore it goes up. I draw it. There's my graph. It goes through negative 5. It goes through positive 3. Open or close circle on negative 5 and positive 3. Open circles. Now, the whole question is, where is this graph greater than 0? Is this section of the graph above the x-axis or below? It's above. How about this section of the graph right here? Is it above or below? It's below. And this section of the graph right over here, is it above or below? Above. So, you're above the x-axis here, you're below the x-axis here, you're above the x-axis here. So you can see that the specific region that is positive is from positive 3 that way and from negative 5 that way. So that is really our solution set. How is this solved? For x values that are less than negative 5 or for x values that are greater than 3. That is my solution set. If you wanted to express it in interval notation, negative infinity to negative 5 or negative 5 or 3 to infinity. Now, somebody really quick, give me a number that's within that solution set. 4. 4 is a number in that solution set. Let's plug it in. Let's see what happens. 4 squared is 16 plus 8 is 24. Is 24 greater than 15? Yes, in fact, any numbers within that solution set would work. So if you can graph it, that's the quickest way to manage these type of problems. But you're going to have to learn how to do the table. which we have just enough time for. I will not give you any homework tonight. Your homework is to continue to work on your homework test. So we now make a table. Again, we start with this. X plus 5 times x minus 3 is greater than 0. We're wondering, where is this graph, in fact, positive? That's the question. Where is it positive? We know where that graph is positive. We just figured it out. But let's figure it out using a table. Here's how you do it. We pick our spots where it's actually equal to 0. Negative 5 and positive 3. We make a box. Over here we put our factors. X plus 5. And I put another one here. X minus 3. And then up on the divisions of the box, I put those actual values of negative 5 and positive 3. A for the day. Who can tell me what value I'm going to get if I actually plug in a negative 5 or a positive 3? I'm going to get 0. We're not interested about that. We're interested about where it's positive or negative. And so if we plug in numbers between negative 5 and 3, or to the left of negative 5 or to the right of 3, we're going to get values that are either positive or negative. And that's what we're interested in. So somebody give me a value that is to the left of negative 5. Negative 6. How about a number between negative 5 and 3? 1. How about 0? I like that one. How about, what about to the right of 3? 4. So those are the numbers I'm going to plug in. It will work to plug anything in at all that you so choose, as long as it fits that interval. So now I plug them in, and I see what kind of value I get. Negative 6 plus 5, is that going to be positive or negative? Negative. Negative 6 minus 3, positive or negative? And what are we doing? What's the operation between these two factors? What are we doing with them? We are multiplying them. So a negative times a negative is a positive. So if you plug in a negative 6, you're going to get a positive result. Let's try again. Let's plug in a 0. 0 plus 5, positive or negative? Positive. 0 minus 3, positive or negative? Negative. Multiply positive and negative, and you get negative. We go to number 4. 4 plus 5 is positive. 4 minus 3 is positive. Positive times a positive is positive. So you can see here that the question is, where is it positive? From this result and this result, we can see that that would give us one solution, and that would give us the other solution, which is identical to what we just had. And so we would answer the question the exact same way. X values that are less than negative 5, or X values that are greater than 3. Now, which way is easier, do you think? To make a graph or make a table for this type of equation? I think the graph is easy. You just draw a quick sketch, and boom, you're done. However, the previous problem I showed you that involves rational expressions, you can't really look at the graph so easily with those. And so it's easier for those to make a table. So you're going to have to be able to practice both. Tomorrow, I'm going to give you a nice assignment class after you do a couple warm-up problems where you can work during the hour on practicing inequalities. And that's all the excitement I have for you today. You have 7 minutes to visit, to look at your homework test, to answer calculus questions, all sorts of things.